Hello there. You're welcome to another segment. Uh, this is Global Entertainment's educational segment, and I remain the same person. My name Abimbola Temitope. So today we are going to do one of the wonderful or a very important topic in mathematics, which is called logarithm. And before that, I could remember the last time we met, I gave you some questions to practice at home. How many of you practice it? Okay. Let's quickly look at the questions so that we will not leave it undone. Okay, what are the questions we have? The first one says, if we have 5 raised to power x minus 3 over 125 index 3x minus 4 is equal to 1. That is the first question. Now let's solve it together so that we know how many people get this. Okay, first and foremost, if you look at this, we have a base of 5. We have a base of 5 at the numerator level. And before I forget, numerator has another name. This is AB. This is what we call numerator. Why this one is called denominator. Now, another name for numerator is called dividend. I mean, D-I-V-I-D-E-N-D, dividend. Why another name for denominator is called divisor. Do you understand? I believe you can see this in some of the textbooks. So you will understand that dividend means numerator, while divisor means denominator. I believe we are good to go. Okay, this is our numerator base 5 raised to power x minus 3 all over 125 raised to power 3x minus 4. If you could remember, I told you that when you have a bigger base like this, you have to break it down to the what? To the least base. And the least base we have here is 5. What we have here is 125. Let's break 125 down into the base of 5. Okay, let's do it together. 125. Okay, some people are giving me the answer already. Okay, how many 5 can we see here? We have 25. 5 again here, 5. 5 again here, 1. That is how many 5? 1, 2, 3. That is 5 raised to power 3. It means that 5 raised to power 3 is the same thing as 125. That is 5 in 3 times. Definitely, we are going to say 5 raised to power x minus 3 over, this is 5, remember, raised to power what? 3. And if you could remember, look at it very well. We have an existing what? Existing value, existing index, existing exponential. So we are going to take our existing exponential, b2 exponential, remember we have to put it in what? In a bracket. So let's put it in a bracket. We have what? Bracket open 3x minus 4. Then all is equal to what? Is equal to 1. And look at this one. There's nothing we can do with this one. And if you can remember, one of the rules of the algebra is that what? You cross multiply. Whenever you have what? An equal terms, you cross what? You cross multiply the denominator and the numerator we have here. So what are we going to do? This one will stand alone. So we have 5 raised to power x minus 3 is equal to, what do we have here? 1. Then we cross multiply this times, we have 5 raised to power, use this 3 to open the bracket. Okay, bracket of, we have 3 times 3x is what? 9x, correct. We have 9x. Then we have, what do we have here? Minus 3 times 4 is what? Is 12. So what we have here now is 5 raised to power 9x minus 12. Now, let's make this one 1. 5 raised to power x minus 3 is equal to 1 times 5, giving us 5 raised to power 9x minus 12. So what do we need to do? We cancel the what? The base, because we have equal base. 5 is equal to what? 5. So we cancel this. So what do we have left? X minus 3 is equal to what? 9x minus 12. So what do we need to do? We collect the what? The like terms. We collect the what? The like terms. Now, okay. Now, what do we have here now? We have x. If we want to collect the like terms, okay, let me write it. Collect the like terms. Collect the like terms. Collect the like terms. So let's collect the like terms. Let's collect the like terms. So what do we have here? We have x. We have x. If you transfer this 9x to the other side, it's going to give us minus 9x because it's positive. Is equal to what? What is left here is what? Minus 12. So if you carry this minus 3 to the other side, we give us plus 3. So what do we have left now? X minus 9x. Remember, x is the same thing as what? 1x. A is the same thing as what? 1a. So what do we have here? We have 1x minus 9x. In our native time here, if they are teaching us something like this, it's okay. You have 1 naira, that is 1x, and minus simply means you are owing. Yes, in our local knowledge here, you say you have 1 naira, you are owing 9 naira. So if you are owing 9 naira and you have 1 naira, so definitely when you pay that 1 naira, you are still owing what? 8 naira. So 1x minus 9x will still give us what? Minus 8x, because you are still owing. So it's going to be negative. Is equal to minus 12 plus 3. Minus 12 plus 3. Minus 12 plus 3 is going to give us what? Minus 12 plus 3 will give us minus 9. You have 3 naira and you are owing how much? 12 naira. So pay 3 naira from the 12 naira you are owing. You still have 9 naira left. So what do we do now? We are looking for x. Remember, we are looking for x. Now, what do we do? What is the coefficient of x here? Minus 8. So what do we have here? We now have what? Divide both sides by the coefficient of x, which is minus 8. So minus 8x over minus 8 is equal to minus 9 over minus 8. Minus 8 cancel minus 8. So what do we have left? X is equal to minus cancel minus. We have 9 all over 8. Or to the what? To the simplest form. Say, how many 8 can we see here? One no number, it remains what? 1 all over 8. Now, that is the first question. Because of time, let's quickly solve the second question. The second question says, we have if 4 raised to power 3x over 2 is equal to the root of 8 raised to power x all over 4. The question now says we should find x. The question says we should find x. Now, mere looking at this, what are you going to do? You have to what? Remove this what? The second root. If you could remember, I gave you the laws of indices, and I told you that if you have something like this, it's the same thing as what? It's the same thing as second roots. Once you don't have anything here, it's the same thing as second root. That means we have second root of what? Of 8 power what? Power x. So what do we need to do? We just say 4 raised to power what? 3x over 2 is equal to what? What is this? And I told you if you have something like this, it's the same thing as what? It's the same thing as a raised to power, what is this? Second root, that is square root. Power 1 all over 2. So that means if I have something like this, cube root of a means a raised to power 1 all over 3. That means if I have the quadrant root of a, it means a raised to power 1 all over 4. Now look at this now. This is the square root of 8 raised to power x. Definitely what we have here is 8 raised to power what? X times, you know what is the square? 1 all over 2. Then everything over 4. Everything over 4. Okay. Now, what do we need to do now? What do we need to do? You can cross multiply. If you like, just like this one, you can just say we have 4 raised to power 3x over 2. Then if you cross multiply here, it's going to be times 4. You know, 4 as the whole number means 4 raised to power what? 1. Thank you. So 4 raised to power 1 is equal to, what do we have here? You can also break this one down. You can break it down. Definitely, we can break it down to the power of what? To the base of 4. Because if you say 4 raised to power 2, that is going to give you 4 times 4. And what is 4 times 4, everybody? 16. Thank you. 16. So definitely we can use 4. Now, what are we going to use? Can you tell me what are we going to use? Which number are we going to use? 2. Correct. So we have 2. If we are using 2, definitely all the other bases must turn to what? Must turn to 2. So what do we have here now? So let's turn this 4 also to what? To 2. Definitely 4 we now turn to what, everybody? 4 we turn to what? Okay, let me first try this one. I've cross multiplied this. 8 x times 1 over 2 will give us what? That is x over 2. Because 1 times x is what? X, then all over 2. This one is okay. Now let's turn everything to what? To 2, to power of 2. Because we come to what? To 4. So this one will now give us 2 raised to power what? This one will give us 2 raised to power what? Raised to power 2. Remember, we have an existing index raised to power 3x over 2. Then times, what about this? 2 raised to power 2 is equal to, what is this? 2 raised to power what? 3. Because 2 times 2, 4. 4 times 3 is what? 8. Remember, we have an existing what? Value here, index times x all over what? All over 2. These 2, we cancel these 2. So what do we have here left? 2 raised to power 3x times 2 raised to power what? Raised to power 2 is equal to, what do we have here? 2. 3 times x is what? 3x all over 2. Now, remember, the law says once we have the same base, and we have either times or division, we're going to pick one. So definitely let's pick one here. We have 2 raised to power 3x because it's multiplication. So what are we going to use? Plus, yes, thank you. Plus what? Plus 2 is equal to 2 raised to power 3x all over 2. The base, we cancel the base. So what is left here is 3x plus 2 is equal to 3x all over 2. We can also cross multiply here. So in order to get the value of what? Of x. This one will now give us 2 brackets 3x, 2 brackets 3x plus what? Plus 2. Plus 2 is equal to, what is left now? 3x. Thank you. Now let's open the bracket. 2 times 3x is what? 6x. Plus, what is the next one? 2 times 2 is what? Is 4. Is equal to what? 3x. Now we collect the what? The like times. Now let's collect the like times. We have 6x. Carry this one to this side. We give us what? Minus 3x is equal to plus 4. We turn to what? Minus 4. So 6x minus 3x is what, everybody? That is 3x is equal to minus 4. So we are looking for x and look at the enemy of x. What is the enemy of x here? We call this one enemy of progress. So that is what? 3. So we use 3 to divide both sides. So what we have here left is what? X is equal to minus 4 all over 3, which can also give us minus, how many 3 can we see in 4? 1 number, 1 all over 3. And that was what you were given the last time we met. Okay, quickly. Okay, now today we are moving to another topic. We move to another topic, and the topic is logarithm. Logarithm, that is a topic. And I want you to know something, that indices and logarithm, they go pari passu. That means they go hand in hand. Once they teach you indices, logarithm always follow. Indices, logarithm, indices, logarithm. And do you know the funniest part of it is that both of them are 7 commandments. I call it 7 commandment, not the commandment of God. So 7 commandments. It means indices have 7 laws, while logarithm also have what? 7 laws. Now let's quickly look at that. Okay. Okay. What do we understand by logarithm? What do we understand by logarithm? Logarithm? Logarithm. So let me pluralize it. I have logarithm. I have logarithm. Now, what do we understand by logarithm? Now, okay, I shall write it. Okay. The logarithm of a number, the logarithm of a number, the logarithm of a number to a certain base. The logarithm of a number to a certain base is the power, is a power to which the base must be raised to obtain the number. Remember, take note of that word. The base must be what? Must be raised to obtain the number. The base must be raised to obtain the number. I believe you understand what I'm saying. Now, let me give you an instance. If you have something like this, you say if we have log n base b is equal to x. And remember, according to the definition, we say the logarithm of a number to a certain base is the power to which the base must be raised to obtain the number. Now, I want you to pronounce this for me. What is this? What is this? I want you to pronounce this for me. Pronounce this. Okay, somebody say log b. No, it's not log b. Okay, another person. Log n. This is log n. Log n base b. Log n base b. Do you understand? This is log n base b equal to what? To x. Log n base b equal to x, not log b base n. Do you understand? This is the subscript. Just as if we are talking about the subscripts in science. So this is a subscript. So we have what? Log n base b. Now, for instance, if they give you something like this, do you know what we're going to do? According to the time, they say what? The base. Which one is the base, everybody? This is the base. Abi? B is the base. Thank you very much. B is the base. The base must be raised. The base must be raised to obtain the what? Number. What is the number here, everybody? X. Thank you very much. X is the number here. So this base must be raised by this x. So we're not going to say what? It means then b raised to power what? X is equal to, what is the number? N. And that is it. That is the illustration. the base must be raised. And we raise the base by this x. You can use any number here. So you're going to see when I give you example now. B raised to power x is equal to, what is the log? N, for example. Now let's do some examples now. Examples. Let's look at some questions here. The question says, evaluate. I'm going to work on 4. Then I'm going to give you maybe you're going to work on some question. Log 1000 base 10 log 1000 base 10. Then the second one, we have log 81 base 3. And the C part, we have log 0.125 base 2. And the third one, we have log 0.2 base 5. 0.2 base 5. Okay? All right. Now, let's quickly work on this. Let's work on this. Okay. What is this? The first one. Remember, for every problem, there must be what? Solution. So let's solve this question now. Let's solve this question. We have the first one is what? Is log 1000 base 10. And if you could remember, the base, this is the base. What is the base here? 10. The base must be raised. Remember, the base must be raised. Now, we have, the question is log 1000 base 10. Use any letter is equal to what? Okay, somebody say y is equal to y. You understand? And remember, the base must be what? Must be raised. Thank you very much. Definitely, we have what? 10 raised to power what? Y is equal to what? What do we have here? 1000. Thank you very much. Just like the what? The illustration given here. So the base must be raised. 10 raised to power y is equal to what? Is equal to 1000. Is equal to 1000. Now with this now, we must break our what? Remember, just like indices, I told you that indices and logarithm, they work hand in hand. Now, we have a base of 10 here, and we have a base of 1000 here. So you have to what? Make sure that this 1000 looks tantamount, looks the same to this other one. Definitely, we are going to break this what? 1000 down. How do we break it down? Into 10. 1000 into 10 is going to give us what, everybody? That is 10 raised to power 3. How do I get that? If you take 1000, use 10 to divide it. This one will give you what? 100. 10 again. So this one will give you 10. 10 again, 1. 10 times 10, 100. 100 times 10, 1000. That one is going to give you what? Will give us 1000. Now, that means this one is what? Is 10 raised to power what? 10 raised to power what? Raised to power 3. 10 raised to power 3. Now, with this 10 raised to power 3, 10 raised to power 3, we are not going to say what? What do we have here? 10 raised to power y is equal to 1000 will give us 10 raised to power 3. I believe you still understand how I got this 10 raised to power 3. That is 10 times 10, 100. 100 times 10, that is 1000. And what do we have here? 10, we cancel 10 here because the base are what? Are equal. So what is my y? My y is equal to what? Is equal to 3. You can see it's very, very simple to get. Once you follow the definition, the base must be raised to obtain the number. Now, let's look at the second question. The second question says we have log 81 base 3. Okay, which letter do you want us to use? Somebody say K. Okay, K is equal to K. So what do we do now? Remember, according to the definition, the base must be raised. And what is the base? 3. The 3 must be raised. So definitely we are going to have 3 raised to power what? Raised to power K. All is equal to the log. And what is the log? 81 is equal to 81. And remember, I told you that the what? The base number must be equal. Must be what? Equal. And how do we make it equal? Definitely we have to break 81 down into the base of what? Of 3. Not every time. Not every time. Sometimes it is the power that will be equal. Don't worry, when we get to that particular area, you will understand. Now, 81. Let's break 81 down. Okay, somebody say 3 raised to power 4. Okay, let's do it. 3 in this one is going to give us what? 27. 3 in 27 is 9. 3 in 9 is 3. 3 in 3 is what? 1. How many 3 do we have now? 3 times 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. 27 times 3 is 81. That is 3 raised to power what, everybody? 3 raised to power 4. 1, 2, 3, 4. So we have to turn our 81 to 3 raised to power 4. Definitely this 3, we cancel this 3 because the bases are equal. And once the bases are equal, we have to what? We have to cancel them. And what is left now? The power. We have K is equal to what? Is equal to 4. That is example number 2. Then example number 3. Example number 3. Remember, the topic is logarithm. Then C. What do we have? We have log 0.125 base 2. 0.125 base 2. What do we have here, everybody? So definitely we're going to add what? Let's add a what? A number. And what is that number? Somebody said we should use X. And remember, the base must be what? Must be raised. We have what? 2 raised to power what? X is equal to what? Is 0.125. How many of you still remember all these unit, tens, hundred, thousands, million, 10,000, 100,000, 100 million, blah, 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 blah? You still remember this? Since primary school days. So when we have something like this, okay, let me bring you back. 1, 2, 3, 4, 5, 6, point, 1, 2, 3. You know, if you can remember number before the point from this place, 6 is what, everybody? Unit. Thank you. 5 is what? Tens before the point. Remember from the back. 4 is what? We have what? 100. And 3 is what? 1,000. 2 is what? 10,000. Because we don't have unit again. After this unit, no more unit. So we have 10,000. Then after 10,000, we have what? 100,000. Then after 100,000, the next number that we follow will be what? Million. And we're going to have what? 10 million, 100 million, etc. Now, the number after the point. After the point, there's nothing called unit. Unit is absent. After the what? After the decimal point. So what do we have here now? What we have here now is that after the point, there's nothing called unit. So after unit, what do we have? Tens. And this is decimal. This one is going to be what? Tenth. And do you know the meaning of tenth? Tenth simply means 1 all over 10. Tenths. And if you divide it, you are going to see that you are going to get is 0.1, which is the same thing as this 0.1. And after the tenth, what do we have? 100. And what is 100? 2 all over 100. If you divide it, you are going to get what? 0.02. And after the 2, what do we have? We have 3 what? 3,000. Thousand. You can see TH is there. That means 3 all over 1,000. And the same thing is applicable to this. What do we have here now? You know, we have 2 raised to power x is equal to, what is this? 125. 125 all over. We have what? What is this, everybody? Tenths, hundreds, and what? Thousand. Thank you very much. That is 1000. So 2 raised to power x is equal to, let's divide this. Let's divide this. Let's divide this. Let's see what we have here. 125 divided by 1000. 25 here is what? How many 25 can we see here? 25 here is 5. 25 in 1000 is going to give us what? 25 in this one is going to give us 40. So 25 in 1000 is 40. Then we can still divide this. 5 here 1. 5 in 40 is what? Is 8. So what do we have here? We have 1 all over 8. And remember, indices and logarithm, once we have fraction like this, what do? We power it. How do we turn this fraction to power? Remember, 1 all over a is the same thing as what? A raised to power minus 1. 1 all over a raised to power 2 is what? A raised to power minus, because 1 all over means minus. Minus, what is this? 2. Do you remember? So the same thing is applicable to this. 2 raised to power x is equal to what? What do we have here? 8 raised to power minus 1. Thank you very much. 8 raised to power minus 1. 8 raised to power minus 1. So what do we have now? We have to break this 8 down into the power of what? Of 2. So definitely we have 2 raised to power x is equal to 8 is what? Break it into the power of 2. 2 times 2, 4. 4 times 2, 8. That is 2 how many times? 3 times. Correct. That is 2 raised to power what? 3. You know, remember we have an existing what? Power. That is times minus 1. And what do we have here? These base are the same. So what do we have? X is equal to 3 times minus 1 is what? Minus 3. And that is the third one. And the last one is what? Is log 0.2 base what? Base 5. That is the last one. Okay? Okay. Okay. Now, is equal to what? Let me use y. Is equal to y. Definitely remember, the what? The base must be raised. So we have 5 raised to power y is equal to 0.2. So what do we have? 5 raised to power y is equal to what? You know, this is 2, isn't it? That is 2 all over. What is this 2, everybody? Tenth. Thank you very much. Tenth. And what is tenth? That is over 10. So, and we can divide this, remember? We can divide this 5 raised to power y is equal to 2 here 1 and 2 here is 5. We turn this one just like this one. So we make it power. So it's going to be 5 raised to power y is equal to 5 raised to power minus 1. Thank you very much. And the bases are the same. So we have to cancel this. Cancel this. Y is equal to minus 1. And that is our answer for that one. Okay. Okay. Now, this is the first one. The answer is y is equal to 3. The second one, k is equal to 4. The third one, x is equal to minus 3. Y, the fourth one, is y equals to minus 1. Minus 1. Now, okay, because of time, I want you to do this one at home for me. Evaluate just 2 questions. We have log 1 all over 2 to base 2. And the second one, we have log 64 base 4. And before I end today's segment, so let me quickly give you the laws of logarithm. I will just write it, copy it. So when next we meet, we quickly work on the laws of logarithm. The laws of logarithm. Laws of logarithm. The laws of logarithms. The first law is log xy base b. And log xy base b means what sign is between x and y is what? Times. And once we see times, we're going to say what? We turn it to plus. We separate the what? The log. Log x. Log what? Log y, which is the second one. If it is times, you turn the what? The log to what? To plus. And remember, what do we have here? We have base. So base b, base b. Let me clean this. Let me clean this. So that is the first law. The second law, we have log x over y, then base b. Remember, this one is what? Is division. If it is multiplication, you use what? Plus. You turn it to plus. If it is division, you turn it to minus. And this is going to be what? Log x minus what? What is the second one? Log y. Log y. You can see we use minus. Remember to put the base b, base b. And the third one, we have what? Log b, base b. Once the log are the same thing, the log is the same with the base, it's going to give us what? 1. Log b base b is what? Is 1. And the first one, we have what? We have log, anytime you have log 1, anytime you have log 1 to any base, is going to give us what? Is 0. So remember that. Then the fifth one, we have log x raised to power m base b. Anytime you see something like this, the power is going to come to the what? To the front of the what? To the back. It's going to go to the back of the what? Of the log. So this one is going to be what? It's going to be m. You can see we carry the power. Log what? Log x base what? Base b. And the sixth one, I told you we're going to 7. The sixth one, number 6. The sixth one, we have log a base b. Sometimes it was like this. Anytime we have different what? Different number like this. What are we going to do? We're going to say what? We have log what? Log a. We have log a all over. Then the b we also turn to log. We have log what? Log b. Then we what? We assign a base to it. Let's assign base k, and we have base k to this one. Don't worry, when we get to this, I'm going to give you examples. And the last one is when we have something like this, log x base b, we can also say is the same thing as log y base what? Base b. Then that means that x is equal to what? Is equal to y. X is equal to y. X is equal to y. Now, I've given you the what? The 7 laws of what? Of logarithm. You can see is commensurate with what? With the what? The indices. Now, with this now, I can just give you simple examples based on this. The examples of that number 1, I can say I have log 72 base 10, or I have log, how will I put it? I have log 90 base 10. If I break this one down, log 90, you know, that is what? That is log what? 9. That is log 9 times what? Times 10. Remember, 9 times 10 will give us 90 base 10. So if I break this one down into plus, because it's multiplication, it's going to be what? Log what? Log 9. Because it's multiplication, it's going to be plus what? Log 10. Remember to put the base 10, base 10. Do you understand? That is the first example of this one. And the second one, if you are giving something like this, example under this one, something I have like log Maybe I have like I have log 20 over log 20 or log 2 over log 3, and I have base 4. So what do I need to do? You know, since it's division, it's going to give me what? Log what, everybody? That is log what? Log 2 base what? Base 4 minus, what is the second one? Log what? Log 3 base what? Base 4. Base 4. So we have, and once we have the same log and the same base, remember, it's going to give us what? It's going to give us 1. If I say log Taiwo base Taiwo, will give me what? Will give me 1. Log Kende base Kende, will give me what? Will give me 1. So remember, please take note of this. Now, and another thing I want you to look at is that when you get home and the assignment you are given, I want you to work on it. The assignment you are given. Aside from the assignment, I want you to look at the principles, comparison between indices and logarithm. Comparison, indices, and what? And logarithm. I want you to look at that one too. It's very, very important. It's very, very important. Very, very important. So, now look at this very well. Do you have any question? Look at the law you are giving. The law you are giving, I want you to look at it. We have 7. Do you have any question with this? Look at this. If you have any question. Okay, the one, where is it? Anytime you have something like this, I can have log, examples of this. I can have log 1 base 10. So far it's log 1. It's going to give me 0. It returns to 0. It returns to 0. Take note of that rules. And like this number 5 laws, this number 5 law, if I have log 3 raised to power 2 base what? Base 3. So what will it give me? I have to carry the power to the front, to the what? Back of the log. Is that going to give me what? 2, just like this. You can see m to this place. 2 log what? Log 3 base what? Base 3. So what do I have now? I have 2. Remember, the same log, the same base will give me what? 1. Correct. Thank you very much. So the same log, the same base will give me 1. That is rule number 3. Rule number 3. So log base 3 is return to what? 1. That is times 1. So what is my answer now? The answer is equal to 2. Is equal to 2. So take note of that law. Don't worry, we have many examples that we're going to work on by the time we meet. Okay. No more questions. Check your book. If you have anyone that is not clear, check. Okay. Think I've given you what you are going to do at home. Again, let me repeat myself. Law number 1 says log xy base b is equal to log. Once you see multiplication here, what you are going to, xy is the same thing as x times y, giving me what? Xy. You have what? That is, because it's times, you turn it to plus, because they both have the same what? Base. It's going to be log x plus log y base b. And the second one, if it is division, what are you going to do? You turn it to minus. You pick the log 1 by 1, log x base b minus, because it's division, log y base b. What are you going to do? Use 1. Well, so when you have log 1 to any base, we give you is 0. Then when you have power, the power can come to the what? can come to the back of the log, and sometimes, like some of the question we saw the other time, when you have different log like this, is the same thing as what? Is the same thing as log A all over log B, log A over log B, and you what? You assign different what? Different base. And the next one, when you have this different one as well, so I can say I have log X, which is the same thing as what? Log X base B is the same thing as log Y base B. Log Y base B. Log Y base B. Definitely, if I have something like this, if I have something like log 8 base 10, I can say is the same thing as log n base 10. So what am I saying? It means that 8 is equal to what? N. That means n is equal to 8 because the same what? The same base. Remember, the same base. Okay, this is where we're going to stop today. And I believe can categorically say you understand. You're looking at the way you are looking. Okay, with this viewpoint of mine, I believe I'm able to convince you and not here to confuse you that mathematics is very, very simple and easy to solve. So my name remains the same. I still remain the same. Abimbola Timitope. So see you next time. Until next time. So bye-bye.